Hi, welcome back to the Math Lounge. We're going to be taking a look at intersections of polar curves. I need to warn you that this is hard. In fact, what isn't hard when we're talking about math? But just be aware, it's a difficult subject. And so there will be some suffering, there will be some tears, but let me work with you. We'll get through this together. So let's get back to our PowerPoint, intersections in polar coordinates. What we're talking about are where two curves intersect. And so what I'm going to do is, it'll take me a minute to write this down here. So I need the curve 2 plus 3 cosine, and then r is equal to cosine. Whoops. So there's my two curves. I want to know where these two intersect. Now, I happen to know what these look like. The first one looks something like a lima bean. There we go, that's that one. And then the second one, cosine of theta, I'll do that in red. It looks like this. Ooh, do I have this right? Those don't intersect, do they? Hold on a minute. Interesting. Starts at 1. Maybe I made a mistake here. I'm going to pause and see if I've... Yes, I made a mistake. In my haste, I blew it with that curve. Let me redraw that curve. It's actually doesn't look like a lima bean. It looks like well, it looks like a lima bean where the inside kind of loops around. Okay, whatever. Okay, so you have you can see visually, you can see a couple of points of intersection here. There's this one right here. So if you were to graph this on your calculators, you would see those visually where the curves intersect. So let's find out where they intersect by actually solving. So you know how to do this. You set these equal to one another. So I have 2 plus 3 cosine of 2 theta, or of theta, is equal to cosine of theta. Let's see, we'll subtract cosine of theta from both sides and subtract 2 from both sides, and I get 2 cosine of theta is negative 2, and then divide by 2. Cosine of theta is negative 1. We all know where that happens. That is when theta is equal to pi. And actually, any odd multiple of pi, like 3 pi, 5 pi, and so on. But pi is the time. So pi. Let's plug this back in to one of these two. Let's use this one. Just so r is equal to cosine of pi, which is negative 1. So the point negative 1 pi is a point of intersection. And you can see that right there. That's that point. So you might wonder, well, what about that point there? That didn't show up. The reason that didn't show up is because because that happens to be a point of intersection at the origin, and that's sometimes you get points of intersection where the two curves are at the point but not at the same time or not at the same angle. And so to figure out exactly when that happens, what we're going to need to do is figure out when each of these equals 0. So if there are points at the origin like that, then we're just going to have to do it this way. 2 plus 3 cosine of theta is equal to 0. 3 cosine of theta equals negative 2, which means cosine is negative 2/3. That's not one of our special angles. So I'm going to use this, the cosine inverse of negative 2/3, pardon me. So I'll use this on my calculator, the arc cosine of negative 2/3, which happens to be 2.3005. So theta is 2.3005. But that's not the only angle. That's the first time. So if you think of the angles as getting bigger, as you go around this curve. That's the first time that this crosses the origin. And then the second time it crosses the origin will be like at this angle here. So here's this angle. And so you have the this 2.3005 up here, but there's a mirror image down here. So in order to find what that angle is, this would be negative 2.3005, but generally you don't want to have negative angles when you're computing areas and such. So what I'll do is I'll convert that to, I'll add 2 pi to that. Give me a sec here. And I get 3.9826. 3.9826. So if you needed to know when or like where on this curve you cross the origin, that would be these two places. As far as this one goes, this cosine of theta, that's a lot easier. You're just solving cosine of theta equals 0, which is theta equals pi over 2. Okay, let's move on to another intersection problem. What about these two functions? Where do those functions intersect? And of course, what I'm interested in here most is using this eventually to come up with limits. So 2 theta and r is equal to cosine of theta. So there's my two functions, and I'm going to just set them. Oh, no one's here to tell me that you can't see what I'm writing. So there they are. So I'm going to set these equal to one another. And then I'm going to throw up my hands and give up. No, I'm not going to give up. You know, that's just what a typical non-math student would do. But you guys are math students. You guys can handle this. Don't give up. Look at this and say, okay, how am I going to solve this equation? I have 2 theta on the left, theta on the right. I can't, if I'm going to solve it, I'm going to need the same exact argument. And so what I can do is I can use the double angle formula for sine. Specifically, sine 2 theta is 2 sine theta cosine theta. And I know that you're tempted to cancel cosines, but don't. So I have 2 sine theta cosine theta minus cosine of theta is equal to 0. And this gives me factoring cosine of theta times 2 sine theta minus 1 equals 0. So that means that I've got cosine of theta equals 0 and 2 sine of theta minus 1 equals 0. So the cosine theta equals 0, those are all right angles. So theta is pi over 2, 3 pi over 2. Learn your trigonometry. It's going to kill you if you don't know your trig. I think I mentioned this before, but it's going to kick your butt really bad. But I'll work with you. We can try our best to try to come up with helps for it. And then sine of theta is 1/2 is going to be theta is, we know this, 30 degrees, pi over 6, and 5 pi over 6 are the two angles, at least from 0 to 2 pi. So those are all the places where these two curves intersect. And I'll graph these curves so you can see what they look like. So I've got r equals cosine of theta is just a circle. And r is equal to sine of 2 theta looks something like this. Oops. Okay, I'm doing my best. It's a propeller. But you can see here that this is the angle pi over 6. This is actually the angle 5 pi over 6 because that point is actually negative on this spoke here. So I know it's kind of weird. And then as far as these two go, those are right at the origin, both of them. So it looks like we actually have 3 points of intersection instead of 4 because those are the same point. Whew, okay, so how are we going to use this? Well, we're going to use this to compute areas. So here's an example of an area that we're going to compute. I want to find the area that is inside the region common to these two curves. Here's a graph of that, or at least what it looks like. I'll move this out of the way. So here's a graph of those two curves. The green one is r equals 3, and the red one is r equals 2 plus 2 cosine theta. And so if I'm going to compute this area, the area common to these, essentially, and I'm going to have to reproduce this here, so my apologies. So I've got this cardioid, and then I've got this circle, which is not the greatest drawing, but it'll work. So here are my axes. So here's the plan, the game plan. What I'm going to do is I'm going to compute the area inside the circle from down here. Whoops. Oh, that is really bad. Just a minute. I have to fix this. Okay, there. It's not the greatest, but it's better. Okay, so I'm going to, from here to here, in this wedge, that I'm going to use the circle. So I'll do the integral from, we'll call this alpha to beta. And that's going to give me, and this is going to be the circle. Whatever. I actually have to square it and do 1/2 because that's the formula, is 1/2 f of theta squared. And then on the back side here, from here all the way around to there, I'm going to use the area of the cardioid. So I'm going to add this to 1/2 times this from beta to, it's not really, I'll go alpha prime. So because it's the same angle, only 360 degrees forward, but it's the same, it's coterminal. And this is going to be a cardioid. Okay, so let's actually do this. To do it, I need to know where those points of intersection happen. And so let's go ahead and set 3, the circle, equal to 2 plus 2 cosine theta. And let's see, subtract 2 from both sides. So I get 1 is equal to 2 cosine theta, which gives me 1/2 equals cosine theta, which means that theta is equal to pi over 3, negative pi over 3. That's going to be my alpha and beta. And then going forward a full circle, this is going to be the same as, let's see, 12, just a minute, 2, 6, 5. 5 pi over 3 is the same, it's the same angle. So going back here, my alpha is negative pi over 3, beta is positive pi over 3, and then what I'm calling alpha prime is 5 pi over 3. Okay, now that I've got that squared away, we can actually do this. We have the integral from negative pi over 3 to positive pi over 3, don't forget the 1/2, times r squared. In this case, the circle is r equals 3, so it's just 3 squared. Next, we have the integral from pi over 3 to 5 pi over 3 of r squared, 1/2 again, r squared. In this case, you have the cardioid. So this is going to be 1/2 times 9 theta. This is the easy part. Plus 1/2, and here we're going to have to use 5 pi over 3. We're going to have to square this. 4 plus 8 cosine of theta plus 4 cosine squared theta. And we're going to have to use the power reducing formula. Let me just do this quickly. This 9 times theta, I believe when I get done. You can do this as well on your calculator or whatever. I believe that just simplifies to 3 pi. Let me just double check. 9 3 pi, 6 pi divided by 2 is 3 pi. Yep. Okay. So we have 4 plus 8 cosine theta plus 4 times, using the power reducing formula, 1 plus cosine of 2 theta over 2. So my 3 pi that came from the circle part is still there. Now I can finally do my antiderivatives. 4, the antiderivative is 4 theta. 8 cosine theta becomes 8 sine theta. 4 times, let's see, that 1 half, well, let's cancel the 4 with the 2. Make it easier on ourselves. Okay, so there's, basically I've just dealt with this there. Anyway, the 1, the antiderivative of 1 is theta. The antiderivative of cosine 2 theta is sine 2 theta divided by 2. And we're evaluating this from pi over 3 to 5 pi over 3. So now we have to be super careful because we have limits that are non-zero. They're not easy. Let's do it though. So the 3 pi is just going along for the ride. And I'll do the upper limit first. 5 pi over 3. That's 20 pi over 3. That's 4 times theta. 8 times sine of 5 pi over 3. Let's see, the sine of 5 pi over 3 is the negative radical 3 over 2. So this will be negative 4 radical 3, because radical 3 over 2 times 8 is 4 radical 3. And then I've got 2 times 5 pi over 3 plus, now it's the sine of 2 times 5 pi over 3, which is 10 pi over 3. And that is also has a sign that is negative radical 3 over 2. So this is going to be negative radical 3 over 4 because there's a 2 there already. That's just the upper limit. I've still got to do the lower limit. So 4 pi over 3 plus, now the sine of pi over 3 is radical 3 over 2. So this is going to be 4 radical 3. 2 times pi over 3. And then here the sine of 2 pi over 3. So I'm just plugging this into here now. Sine of 2 pi over 3 is negative, or no, it's positive radical 3 over 2. So this will just be radical 3 over 4. Wow. Let's clean things up. Let's hope that we can clean them up. So what do we got here? This is going to be 20 pi over 3. This is 10 pi over 3. So that's a total of 30 pi over 3. And then we're subtracting from that 4 pi over 3 plus another 2 pi over 3. So we're subtracting 6 pi over 3. So it's going to be 24 pi over 3. And that takes care of that, that, and that. Now let's deal with the radical 3's. I have negative 4 radical 3 minus another 4 radical 3 because of the minus here. So maybe I'll just write this like this. That takes care of those two. And then we've got 2 times negative 4 radical 3. And this is 2 times, but we have this negative as well. So this ends up being a total of negative 4 radical 3 over 4, which is just radical 3. Oh, what a pain, right? Okay, so we got 1/2 times 24 pi over 3, which is 8 pi times 1/2 4 pi. So that's going to be a total of 7 pi plus or minus 9 radical 3 over 2. Done. Phew. All right, I think that's enough for this video. You got questions? I know you do. Bring them to class.